Hello Math 130 students, we are going to pick up on page 19, section 6.8, complex numbers. So this is the very last section in chapter 6. So what do we have? We have imaginary numbers, which is kind of cool. So we know two things. We know that the imaginary number is denoted as I, and I is represented as the square root of -1. The other thing that we know is that when we square that square root of -1, we get -1, okay? So every imaginary number has a square root -1 as a factor. It is denoted by the letter A. When I have a complex number, it is written as the real number A plus B plus I. So let's rewrite these numbers in the form A plus BI. So here, you want to take into account that this is an imaginary number. So you can't, I know that the square root of 49 is definitely 7. But now that I have that negative in there, I have to be really careful. I have to know that this is really since it's negative, that negative gets pulled out of the square root as a I. So now I have I times my 7. And to rewrite it in the form, I have 7I as my answer. For number 2, same thing. I have my I. That's going to take into account that negative. And then I have the square root of 10. But if I look at 10, that's just 2 times 5, so that can't really be simplified any further. So I just have I square root 10 as my final answer. Now, let's think about this. I have a negative on the inside, so I know when I take that out, I have a negative, and now I have that I, and I have the square root of 4. Well, since I have that negative I on the outside, well, the square root of 4 is just 2. So this is really negative 2I as my final answer. Now we're going to add and subtract. So when adding and subtracting, we can really just add things that are alike. So I have my -4 plus 2. And I have a positive 5I and a -4I. So I can combine like terms. Well, if I have -4 plus 2, that would give me a -2. And a positive 5 minus a 4 would give me a positive 1I. Or I can just write it as -2 plus I. Either way, it's fine. Now with the subtraction, I have to be more careful because I need to think about this as a -1 that's going to get distributed. So it's a -1 that gets distributed inside my parentheses. And actually, make sure that you know that you are multiplying the coefficient times the coefficient. So we have our 7 minus the square root of -4. And now when I distribute that negative, it's going to be a positive 1 and a positive square root of a -16. Okay, so remember, it's the coefficient times the coefficient. So now I'm going to do my like terms. So 7 plus 1, well, that's going to give me 8. And I have my negative, and here, because I have a negative, I'm going to say that's I, and I have my square root of 4. Plus, and here I also have a negative, so I'm going to have my I as that negative represented as my I, and I still have that square root of 16. So now I have 8 minus, and I have my I, and the square root of 4 is 2. Plus I have my I, and the square root of 16 is 4. So I really have 8 minus 2I plus 4I. So when I combine like terms, that 2i and that 4i are going to combine. so that I have a plus 2I as my final answer. So that is how we add and subtract our imaginary numbers. You just look at the coefficient and you want to make sure that anything underneath the radical, so the radicand that has a negative, take out that negative so you know you can have a positive inside. Now, don't forget when you're multiplying imaginary numbers, the definition of I is the square root of -1, right? That's how we factor out that negative, it becomes I. But don't forget that I squared is equal to -1. So that's really cool. Whenever I square I, it's -1. So let's think about how this is going to work out. So if I were to distribute, I have a 15 times a -5, which is going to give me a -75, and I have my I value. Now, when I distribute here, I have 15 times 13, which gives me a positive 195, but I also have my I that's being multiplied by another I. So that is going to give me an I squared. So I have -75I plus 195, but that I squared is really a -1. So -75I minus 195. But remember, we want to write it in our standard form, which is that A plus BI. So the real number part comes first, then the imaginary numbers. So that would be -195 minus my 75I. So then that would be my final answer. For number 2, the first thing I want to think about is that negative. So I can pull out that I. So now I can deal with the square root of 147 being multiplied, and again I have the I that's being pulled out, and now I have 192. So if I have 147, let's see if I can factor this. Well, I know that 3 times 49 is 147, and 49 is 7 times 7. So I can rewrite this as I, and now I have on the inside 3 times my 7 squared, because I have 2 7s here, being multiplied by my I. And now let's break down 192. Well, I know that 192 can be divided by 2. So that's going to be 2 times my 96. 96 divided by 2 is 48. So let's see, 48 divided by 2 is 24. 24 divided by 2 is 12. So that's 2 times 6, which is 2 times 3. So I have 2 to the 1, 2, 3, 4, 5, 6 power times 3. So I know that I'm going to rewrite this as 2 to the 6th power. That's going to get multiplied by my 3. So now, because I know that my index is a 2, because that's what it defaults as a square root, well, I know that this red 2 divides this exponent of 2, so the 7 can jump out. So I'm left with 7I square root 3 times, and now this 2 gets to jump out. And remember, I divide by that index. So 2 to the 6 divided by 3, 6 divided by 3 is squared, and 2 squared is 4. So now I have 4I square root 3. And since this is being multiplied, well, I multiply the coefficients. So 7 times 4 is going to give me 28. I times I is I squared, and I have the square root of 3 squared. So now I can simplify this a bit more. Let's give myself some more room here. So now I know that this is 28. Well, that I squared, don't forget, is really -1. So that's a -1. And here, when I have the square root of 3 squared, well, the square and the square root cancel each other out. So you're just left with a 3 on the outside. So you really have 28 times a -1 times a +3, which gives you a -84. All right. So now for number 3, for this one, I think what I want to do is I want to go ahead and do a box method. If I do a box method, I think that's going to help me. So I have a 10. And I have the square root of a -200. Actually, my numbers are going to be way too big if I multiply the -200 and the -200. Why don't we simplify this a little bit? If I have the square root of -200, well, I know that that negative inside becomes my imaginary part. So I'm left with the square root of 200. And the square root of 200, well, if you want to think about it, oops, not equals, but times the square root, 200 is really 2 times 10 squared. So this becomes 10i square root 2, since that 10 jumped out. So now I'm going to rewrite this. I have 10 plus 10i square root 2 times my 4 plus my 10i square root 2. So now this is where I'm going to do the box method. So I have a 10 and I have a 10i square root 2 and I have a 4. Oops, let's make that a little bit bigger. And I also have a 10i square root 2. So now 10 times 4 is my 40. And here 10 times 10 is 100. And I have my 100i squared times the square root of 2 times the square root of 2, which is 2. So remember that I squared is equal to a -1. So this is really -100 times 2, which gives me a -200. So really, this ends up becoming 40. And I can add the diagonals. So 40i squared plus 100i squared is going to be 140i square root 2 minus my 200. And of course, I can add things together. So 40 minus 200 is going to give me a -160. And I still have that 140i square root 2. So I decided to make my life a little bit easier by simplifying before I multiplied. And then also I simplified that 100i squared to times 2 to that -200. So for number 4, again, I can either do the box method or I can go ahead and just do the FOIL method. I'm going to do the box method. So I have a -10 and a 12i. And I have a -10 and I have a -12i. If you already see the pattern, that's great. Then that means it's going to be less work for you. And the pattern that I see is that these are conjugate pairs. And whenever you have conjugate pairs, when you FOIL, you already know that the outer and the inner are going to cancel out. So you already know what's in this box and this box are going to cancel out. That's your outer and your inner. But let's prove it. So we have negative 10 times negative 10, which is a positive 100. Now I have a negative 120i, and here I have a positive 120i, and 12 times a negative 12 is negative 144, and I have my I squared. Well, remember that I squared is a negative 1, so negative 144i squared is really negative 144 times negative 1, and a negative times a negative is a positive 144. So this really becomes a positive 144. So now I know that I have my answer of 100. My middle boxes cancel. That's what happens when you multiply the conjugate pairs. We already knew that was going to happen. And I know that negative 144i squared kind of simplified a little bit to give me 144. So 100 plus 144 gives me my final answer as 244 as your final answer. Now what we can do is we can also have division by complex numbers. So this is just like rationalizing the denominators, but we don't use that terminology because now our denominator is imaginary. So instead we say we divide by the complex number. So really when we divide, we're really going to be multiplying by I on both sides, because then I have a 5 minus I times your I, and at the bottom I have an I squared. Well, I know when I distribute that I'm going to have a 5i minus an I squared, but I already know that I have an I squared. So I know that an I squared is really a negative 1. So I'm going to have 5i plus 1 over negative 1. So I'm really going to have this as a negative 5i minus 1. And to rewrite it as a standard form, it would be negative 1 minus my 5i. So negative 1 minus 5i will be my final answer. Now, looking at number 2, I know that I need to multiply top and bottom by my 10i. When I do that, I have my 10i times negative 12 plus I. And down at the bottom, I have 10 times 10, which is 100, and I have my I squared. Well, my numerator, when I multiply that, I'll get a negative 120i plus my I squared. And don't forget, your I squared is just a negative 1. So negative 120i plus negative 1, 100 times my negative 1. So negative 1 minus 120i over negative 100. So that's a perfectly legit answer. Or I also could have written it as 1 over 100 plus 12i. And you might be thinking, well, how did I get from here to here? These represent the exact same value, because what I did is I separated it. So it's a negative 1 over a negative 100 minus 120i over a negative 100. So a negative divided by a negative turns into a positive, and 120 divided by 100 turns into, oh, it wasn't 12, was it? It was 12 over 10. But that can actually be simplified. Oh, good thing I checked my answer, right? I got too happy when I was separating it. So 120 divided by 100 really gives you the fraction of 6 over 5. So I'm going to say this is 1 over 100 plus my 6i over my 5. There. And this is the most simplified. So you always try to simplify as much as possible. And don't go too fast and furious like I did. So you are more likely to make a mistake when you go too fast. Just as, I thought 120 divided by 100 was 12. That's not right. 120 divided by 100 is 12/10, which reduces to 6/5. So that's way different. Okay? Now, for number 3, I want to think about multiplying by the conjugate. So I'm going to have 12 plus 2i. So these are things that are now going to be multiplied. So I'm going to think about foiling these things together. So I have a -1 times 12. So that's going to give me a -12. A -1 times a positive 2i. So that's going to give me a -2i. Now I'm going to think about this -8 being multiplied. So -8 times my 12 is a -96i. And I have a -8 times a positive 2, which is a -16. And I have I times I, so I have that I squared. Don't forget that whenever I multiply conjugate pairs, the outer and the inner cancel. So the only things I really have to think about is my first. So 12 times 12 is equal to 144. And then if I look at my last, I have a -2 times 2. So that's a -4. And I times I is my I squared. So now I'm going to clean this up a little bit. So I have a -12. I have a -2i minus 96i, which is a -98i. And I have a -16 times a -1. So I also have a 144 minus 4 times my -1 as well. So this ends up becoming a positive 16. So -12 plus 16 gives me a 4. And I still have my -98i. And 144 minus 4 times -1, which is the same as 144 plus 4, is going to give me 148. And just like we did before, you always try to simplify. So this tells me I really have two fractions. I have 4 over 148 minus 98i over 148. So I can simplify this fraction, 4 divided by 148, and that's going to give me 1 over 37. And that fraction, 98 divided by 148, is going to give me 49i over 74. And so that ends up becoming my final answer. So let's take a look at this again. So let's look at number 4. So here, let's think about multiplying by the conjugate. So -11 minus 11i. I think here, because there's so many 11s and i's, I'm going to do the box method. I think that's going to help me to be a little bit more organized. So I have my -10, and I have my 14i. I also have my -11, and I have my -11i. So when I do this, -10 times my -11, that gives me 110. -11 times 14 is going to give me -154i. -10 times a -11 is 110i. And I have -11 times a 14, which is -154 I squared. When I reduce that, it's really a negative 1, so 154. Negative 154 times a negative 1 really becomes a positive 154. So now I know exactly what's going to be in my numerator. That numerator, I have 110, and now I get to add my diagonals. So I get to add this number and this number together. So 110 minus 154 gives me a negative 44i. And I also have my plus 154. So that made it a lot easier on my eyes to multiply using the box method. Now, down below, since I have conjugate pairs, I'm going to deal with my first and my last. So negative 11 times negative 11 is going to give me a positive 121. And I have minus, and 11 times 11, again, is 121. And don't forget, I have my I squared. So to simplify this just a bit, I have 110 plus 154. So 110 plus 154 is equal to 264 minus that 44i. And in my denominator, since I know that I squared is equal to a negative 1, it's really 121 minus my 121 times a negative 1. So this negative actually ends up becoming adding. So I get my 242. So now I have 264 over 242 minus 44i over 242. So my fraction, when I simplify, 264 over 242, that's going to give me 12 over 11. And my fraction, 44 over 242, gives me 2 over 11. And I can't forget that I have my I there as well. And you might be thinking, like, how is she simplifying these fractions? Calculator. You're always allowed to use your calculator. Use your calculator if you don't know, if you are struggling with reducing fractions, right? I divide by 2 because it's even, or divide by 4, or whatever it is that's a common factor. You divide top and bottom by the same common factor and keep reducing your fraction. Now, on page 23, we're going to look at the powers of I beyond I squared. So we already know I and I squared, but there's also I3, I4, I5, I6, I7, 8. You can go all the way up to I to the millionth power. It's always going to be represented by 4 distinct answers. So we already know our definition. I to the first power, right? That's going to give me my square root of negative 1. So that's perfect. Or actually, even before that, what's I to the 0 power? Well, I to the 0 power, anything to the 0 power is always 1. So then I to the first power is just I, so that doesn't change. My I squared, as mentioned before, is really a negative 1. And then my I to the third power, as seen here, is a negative I. And the cool thing about this is that now I to the fourth, it repeats the pattern. So now that it repeats the pattern, see, 1, 1, 1, 1. So if I have I to the 12th, that's going to equal to 1. If I have I to the 16th, that's going to equal to 1. So anything that's divisible by 4 is going to give me 1. So what we can say about our i's is that it's cyclic. You might be thinking, what did she just say? Powers of I is cyclic, meaning it repeats every fourth. So that's pretty cool that I repeats on every fourth. That means what we can do is divide the power of I by 4. So the I to the nth is divisible by 4, and whatever the remainder is, so that's what we're going to be looking at. We're going to look at the remainder. That's what our answer is going to be. So, for example, let's look at I to the 14th. I'm going to divide it by 4. So 4 into 14. Our goal is to look at the remainder. Well, I know that 4 times 3 is 12, and 14 minus 12 gives me 2. So my remainder here is 2. So I can say that I to the 14 is I squared, because that's my remainder. Well, I squared, don't forget, I have it over here. I squared is really -1. So my answer is going to be -1. So let's look at a different power. Let's look at 46, okay? So that's fine. So 4 goes into 46. So it goes in here 11 times. 4 times 11 is 44. So 46 minus 44 is 2. So I have the same remainder. So I to the 46 is equal to I squared, which we already know equals to a -1. Well, let's see what else happens. So I have 4 that's going to get divided by 211. So that is going to be a 52. So 52 times 4 gives me 208. If I subtract, I'm going to get 3. So my remainder is 3. So I to the 211 is equal to I to the 3rd power. And to the 3rd power, don't forget, it's over here. I to the 3rd power is -I. So I'm going to say I to the 3rd power is a -I. And so that ends up becoming my final answer. Now, for that last one, I'm going to have 4 into 115. That's going to give me 28. So then 28 times 4 gives me 112. Minus 115 gives me 3. So I have that I to the 115 is I to the 3rd power, and I to the 3rd power is just a -I. So you always want to make sure that you are doing your long division by 4, and really these are the 4 that you want to know. These 4 is what you want to remember. If it was me, I would put this on my 3x5" note card if I'm allowed that on the exam, because that's what it boils down to when you divide by 4. Okay, and that is the end of chapter 6. So if you guys have any questions, email me, the Math Success Center, or your tutor. Thank you.